Welcome back. Have you ever wondered how Uber connects millions of riders and drivers seamlessly every day? In this video, we will explore the intricate system design behind Uber's ride handling platform and uncover how its components work together to deliver a smooth experience for both riders and drivers. So, as always, in any system design video and any system design interview, we have to follow some steps in order to succeed in our system that we're trying to design, or also into succeeding in our interview. And the first thing is to understand what actually we are designing. So I guess like it's easy to know what is Uber and how it works. Most of us have been used. Most of us have used Uber. So the second thing, after understanding what we actually designing, we need to understand our functional requirements and our non-functional requirements. Our functional requirements, we need to have like update driver location, find nearby drivers, request a ride, manage payments, show driver estimated time of arrival, which is the ETA, confirm a pickup, show trip updates, and end the trip. In the non-functional requirements, we need to make our system highly available, scalable, reliable, consistent, and we have to add some sort of payment fraud detection. Okay, let's try to think about how our system will work. So let's go here. We will have to first we will have like a rider, not a rider, which, and let's copy this, and we will have a driver, but let's just make the text white, black, sorry, and this one white. So we have rider and driver, and we need to make sure our system can connect them together. So how we can do that? The first thing, we have the rider, and the rider is the primary user of the Uber platform. They interact with the system through a mobile or web application to request rides. Their actions include entering their location, selecting ride options, and processing payments. The system ensures a seamless experience for the rider by handling requests, real-time updates, and ride tracking. The second thing, we have driver. The driver is the service provider who accepts ride requests and transports the rider to their destination. Drivers also interact with the system via the detected app that provides real-time navigation, ride details, and earning management. So the rider will be connected with like a load balancer. Okay, which will like distribute all the incoming requests. The load balancer will distribute all the incoming requests from both the riders and driver. The driver will be connected with like a load balancer as well. Um, and basically it will distribute the requests from both the riders and drivers across multiple servers to prevent overloading. This ensures high availability and efficient resource utilization. The riders, the for the riders, the balances request for ride booking and updates. For drivers, it balances ride request notifications and location updates. The second thing, we will have a WebSocket server. Okay. The WebSocket server enable real-time bi-directional communication between the client, which is riders and drivers, and the actual server. For the riders, it will have like real-time updates for driver location, the ETA, and ride status. For the driver, it will have like instant notifications for ride requests and real-time navigation updates. Also, the WebSocket server will be for the driver section. Okay. The thing that the driver and the rider will use, I guess, we need to add like a CDN, like a CDN, and oh, it can be like that. And I need to make its color quite like not greenish. Let's make it something dark. Yeah, and it will be connected with here and here. Okay. The CDN here will cache the static assets like app images, styles, and scripts closer to the user to minimize latency. It also ensure quick delivery of critical updates like maps and other static data to both riders and driver, improving the app's performance. Because we said that one of our non-functional requirements, it will be the performance. And I guess since we use the cache, we can talk about Redis as well. Let's copy this one and let's make the cache in this color. So we will use Redis and we will talk about how we will use it. So Redis, Redis is used as high speed in-memory data stored for caching frequently accessed data. It will be for driver locations, like it will cache in real time to quickly match drivers with riders. It will also frequently, in the trip data, it will frequently access during an active trip to minimize load on the primary database. And all of that will be connected with our Uber server. But let's just create like a big server. Let's make this white. Okay. So we have it like this. Okay. In our server, we have multiple things. First, we have what we call a location manager. Let's add let's copy the WebSocket and add here. Like we have a location manager, right? Yeah, I did write it right. Okay. Let's give it. Yeah, let's make it. The location. Oh, okay. I guess I mispronounced it. The location manager is a crucial component that handles. Okay, let me just make this one quite smaller so it will not be as frustrated as it looks. Okay. The location manager is a crucial component that handles all location-based services in the system. It has like rider location. It will identify the rider's pickup point. It will tracks and updates driver location in real time. It will ensure riders are matched with the nearest available driver. So yeah, it's a pretty important item, pretty important component, and it will be connected with the driver via WebSocket, so it's a bi-directional communication. The next thing we have a quad tree map service, which will be connected with the location manager. Quad, why it's quad tree map service. This one is the quad tree map service optimizes spatial queries by dividing the map into smaller sections or nodes for efficient processing. It will have some sort of drivers search. It will quickly identify drivers within a specific region. It will help in calculating the shortest path and ETA. So it has like some sort of route optimization. It handles millions of spatial queries with low latency. So it have some sort of scalability with it. Sorry. So we have the next thing. We have like a request vehicle service, or like, yeah, a request vehicle service. Let's just copy this one. No, what's going on? Let's put it here. And I guess I don't want to like write all of that, so I'll just copy the text. And let's make it like that. We have a request vehicle service. This will be connected with this WebSocket. Okay. This service manages the flow of ride requests from riders. It validates ride details like location and ride type. It triggers the find the driver service to locate the best suited driver. It communicates back to the rider with the status of the ride requests. And between them, we have a find. No. Let's call it find driver. Let's make it bigger. Let's delete. Let's edit here and let's give it a different color. What color should I give it? Let's give it greenish. So the find driver service, it will be connected with both. It will be in between. The find driver service, this service matches riders with drivers based on multiple factors like proximity, like finds the closest available driver. It will also ensure the driver is online and ready to accept the ride. It considers the estimated time of arrival to determine the best match. I guess we have like an ETA service. Service. The ETA service, or like the estimated time of arrival service, calculates the time it will take for the driver to reach the rider and for the trip to complete. It uses real-time traffic data, driver location, and the quad tree map service. It sends ETA updates to both rider and driver. So yeah, so it has a connection with the location manager. It has yeah, but let's just make this like that because I guess we need to put a lot of things in between. I guess we need to add a trip manager. Let me copy this one. Service, trip manager service. Trip manager. So this service, the trip manager oversees the entire life cycle of the trip. It starts a trip, it has like a start trip, so begins the trip once the rider is picked up. It has a track trip, so monitors the progress of the trip in real time in the trip as well. So it marks the trip as complete when the rider is dropped off, and update trip details in the database for billing and history. So it will be connected to the find driver service as well. And yeah, I guess we need to add two more components. So we can add like a payment service for fraud detection. Let's add it here. Payment service. And let's give it a greenish because it's money. Let's make the color black. And I guess the payment service, it will be connected with the trip manager. I guess the trip manager will only have the ability to do that. So the payment service handles all financial transactions, ensuring seamless and secure payments. For riders, it processes payments via credit cards, wallets, or cash. For drivers, it calculates driver earnings and the payouts. It integrates with third-party payment gateways for global operability. So yeah, we don't need to create our own service for that. I guess I added everything and I didn't add any database. So let's add a database. And the database will be connected with the trip. No. Let's give it a color. Yeah, it will be connected with the trip manager. It should be connected with the location manager as well. Okay, so the database store all critical information required from Uber's operation. It has like user data, stores rider and driver profiles. Trip data stores details of completed and ongoing trips. Payment data as well manages transactions, history, and financial records. Yeah. So let's make this smaller. So I guess this is the full system of Uber. We can understand how these components work together for like rider requests. When the rider request arrives, the request is routed through the load balancer to the backend services. After that, it goes through a driver matching step. So the system identifies the best driver using the find driver. It's using a find the driver and location manager services. And there is a real-time updates. The WebSockets ensure continuous updates to both rider and drivers during the trip. After that, the trip manager oversees the entire trip lifecycle from a pickup to drop off, and we have a payment process like at the end of the trip. The payment service finalizes all the transaction and updates the rider and driver. This architecture ensures scalability, reliability, and real-time performance, enabling Uber to operate smoothly across the globe. Let me know if you would like any further details about this, but I guess this is the full system. In the future as well, we will create videos. Oh, I didn't connect to this one. Sorry, I forgot to connect to the Redis. I guess it's connected with the location manager. This is it for this video. In the future, we will make other videos that talks about some changes and some things we choose and why we choose to add this and not that, why you should WebSocket, what is the difference, why we choose a quad tree map service and how does it work. I guess if you don't know how quad tree map service works, you can check our videos that talks about designing Yelp. I guess it will be pretty helpful for you guys. So yeah, that's it for this video, and I hope you like my video.